OK，
就开始就行。
开了。啊
Record.
Yeah.
Okay. Today's class is very simple, so we will focus more on exercises. Okay. But we will introduce one important concept called state machine. Okay. So mainly, okay, let's quickly go over. You know pretty much most of it. So all of you know what is if else, right? Helena, do you know that? Okay. Just 1 second for Helena. So if statement is very easy. You have to follow this syntax. Say if, then followed by condition expression here. Then there's a curly braces between that. The basic logic is pretty simple. If this is true, then this piece of code will execute. Got it? Helena? Okay. So if else is also pretty simple. So basically, if this is true, then execute something here, then else do something there. So there's nothing tricky. Okay, let's quickly go over this. Helena, you know that, right? So for the if-else statement, sometimes Derek, Ming, do you understand this? You know Ming, you know C, right? You know C language, right? Can you tell me what does this mean? This. Let's make it bigger. Basically, sometimes you will see there's a very simplified version of if-else statement. Basically, just make a code very short. So, for example, int mean value equal to if x less than y, then equal to x, otherwise equal to y. Okay? This code basically is the same as this. Okay? If x less than y, then the value of mean was assigned to x, otherwise set to y. Okay? Got it? So this is a very simple one. So this is in slide 6. So it is a program. Hey guys, this is a program basically to simulate flip a coin. So just to refresh your memory a little bit. Helena, do you need glasses? Okay. So here we use a mass random to simulate a coin. The mass random will return a value between 0 and 1.0. 1.0 not included. So as a result, we can simply check the mass random. If the less than 0.5, then say print as hat, otherwise tail. So it's pretty much simple if else statement. Okay. Now let's look at the switch statement. So 天凯，你可以看一下这个屏幕找得到吗？
屏幕这太小，
太小了。那 Can you move closer? So switch statement is another important data structure. Here, right? It's a switch statement. It's a very important statement actually in robotics, because I will tell you why. Because switch statement, we use that to implement the state machine. Okay? So let's introduce the switch statement first. For a switch statement, you need to basically put an integer here. Okay, switch. And if this integer match any case here, then the program will execute what are the statement here. And it's very important that you put a break there. If you don't put break after the case, then there will be a fall through. Basically, we'll keep running all the cases. Okay, so you guys can check it out. So I don't think we need to write a program to do this, but we can do access session later. Okay, so basic idea, very important with switch statement is you need to put a break there. Most common mistake is people forgot to put a break there, and the program behaves strangely, because if you don't put a break here, the statement after this case will go as well. Got it? This is called fall through. Okay, that's very important. Helena, got it? mean? Do you understand it? Alright. Okay, let's go to something related to robotics now. So we call state machine. So do you guys notice what's this? Ming, what's this?
It's
Did you ever go to guys travel to New York, go to the subway, museums, right? So, Elena, can you tell me what's this thing doing? Yeah. So basically, this is a very simple robot. I cannot find another robot more simple than this. To implement this, basically we need to describe the behavior use state machine. Okay? So whatever this is called tense style. So what it's doing, if you say for example it's a subway. If you present your ticket or put a coin there, and this bar will unlock, which allow you to get in. And when you get in and turn it, the bar will get locked. Okay? Okay. The bar will get locked. Then you will go back to original state. So how to represent this behavior? We can use a switch statement, right? Right? Okay. And another concept is you guys need to understand how to represent a state machine, because state machine is a tool to describe how machine react to this world. This is very important for robots. Okay, if you want to communicate with your teammates and describe the business logic you want to put in a robot, and you need to draw the state machine. For example, let's explain this. Okay. For example, this black dot means initial state. Before anything happens, we need to initialize a state. It cannot be either for a program, for robots. You have to initialize to a specific state. Then start a program or start a robot. Otherwise, the consequence of the program or the behavior of the program is unpredictable. Okay? Because the robots right now, they are not quite as smart as human. You need to have set up an initialized state. So the black dot will not present the initialized state. The initialized state of a turnstile, it is in the lock state, right? Okay. When you push it, this is a human behavior to it. When you push it without a coin, still lock, right? Right? When you add a coin, then the turnstile will become unlocked, right? And if you do nothing, it will stay in the unlocked state. Is that right? When you push it, this is getting, right? Then you will turn into a lock state, right? If in the unlocked state you add coins, nothing changed. It's still unlocked, right? Basically, use this state machine diagram. It's clearly describe exactly what happened in this robot, right? So in the future, this is a very simplified example. In the future, when you guys design the behavior of the robot, you need to draw this diagram first, describe, to double check your idea. Okay? Is there any loophole here? For example, if you design a diagram, okay, you forgot to say, because most likely when this turnstile is unlocked, people won't put a coin in, right? Right? But you need to think about it. It could happen. People could put a coin in. What if you put a coin in, you lock it, and will make people unhappy. Is that right? Because this, when you design a robot, you have to think about all the possible input to the robot. For example, if you write a piece of program, try to traverse, say, through a maze. Okay? One way to guarantee a robot get out of the maze. I'll show you the maze. Okay? For example, this is a very simple maze. You write a robot, right? One algorithm guarantee the robot can get out of the maze is robots always follow one side of the wall. You will guarantee to get out. We can prove later, but right? Say theoretically, this is very simple to implement. It just depends on the sensor of the robot. Keep tracking whether on your right side has wall or not. Basically, you can use a distance sensor. So if this is less than something, that means you detect the wall. Just follow it, right? Whenever you follow the wall, so your program guarantee work, right? But exception could happen, right? Your sensor might not work, or there's a special thing somewhere and fool the robot to say, oh, this is or for example, there's 30 points. There's a 30 points on the sidewalk, so your sensor doesn't work, right? So there's so many things you need to think about. Basically, each state. So you might simple robot only have to check one condition, but in reality, you have to check a lot of conditions, right? Okay. So let's move on to switch statement. Okay. So can you guys understand? Double check this switch statement with this logic is the same. Okay. Let's look at the code. Okay. For a state machine, you need to declare a variable called state and put it in a switch, right? Okay. Then you have lots of cases here, right? So for example, this machine only have two states. So just need two cases, right? Maybe you need a fourth state, but by default you do nothing. Okay. So let's check out the case one. Then you have to basically somewhere write in your code to comment it. The case one belongs to lock. You have to document it. Otherwise, how does the other people know state one is locked, right? So, and if coin is at state will equal to 2, and at the same time you unlock it, and the program will get to here and break and get out of the loop, right? So when the second time, because usually this switch statement will run in an event loop. We will introduce an event loop concept later. Event loop, it is basically in a machine or in a computer, there's an internal loop somewhere. We'll keep calling this program. We'll keep calling this program again. By itself, automatically. You don't need to worry about it, right? So, when the machine come back to execute this program one more time, this state equal to 2 now, right? You will jump to case 2. And case 2 is unlock state. Then you say, you have to check if push, then state equal to 1, you change it to 1. Okay? Got it? Then have to lock it. So basically, this is the first implementation of state machine using switch state. Got it? So this is a primary important concept you guys have to get it today. Ming, do you understand this? Okay, cool. Okay, so while loop was also straightforward. You just put a condition here. If this is true, then we keep executing, and inside a while loop you need to modify the power such that we can get out of the loop. Otherwise, it will go to infinity. Okay?